Hi friends, welcome to Data Science and AI Quest channel. In this post, we would be discussing about random variables and probability distributions. Random variables. Let's take an example. Suppose each of the points of a sample space is assigned a number. Then one has a function defined on the sample space. This function is called as a random variable or a stochastic variable, or more precisely a random function, or which can be also called as a stochastic function. This is usually denoted by a capital letter such as capital X or capital Y. So in general form, a random variable has some specified physical, geometrical or other as such significance. Let us take an example. Example is of tossing a coin, and this is repeated twice. So here the sample space consists of the outcomes like HH, HT, TH and TT. So let this number X represent the number of heads that can come up. With each sample point we can associate a number for X. So the sample point that is X consists of all these outcomes, that is HH, HT, TH and TT, and for the value for HH, for the outcome HH, number 2 is assigned in the table. For HT, number 1 is assigned. For TH, 1 is also assigned. For TT, 0. So in this table one can see that all the outcomes of the experiment of the throw of the dice have been shown. Here HH, the outcome HH is 2, which means that on both the throws of the dice the outcome turned out to be heads. So the answer for the sample point X for this outcome is assigned 2. Next, for the outcome HT, capital HT, 1 is assigned, which means that on one of the throws of the dice the outcome is heads, hence represented by 1, and on another throw of the dice the outcome turned to be tails, which is represented by 0. So overall the sample point X for the outcome HT is given by 1. For the outcome TH, 1 is assigned, which means that on the first throw of the dice the outcome is T, and on the second throw of the dice the outcome is heads. So the output is heads, as because the total number of heads is 1. So TH is represented by 1. That means the sample point X for the output, that is TH, is represented by 1 in the random function table. And finally, for the case of the outcome TT, that is capital T and capital T, so on the throw of the first dice the output happens to be tails, and on the throw of the second dice the output happens to be a tail as well, and on both the occasions the event of tails turning up is represented by the symbol 0. So overall representation of the event is shown to be 0 as well. So it can be noted that many other random variables could also be defined on this sample space. For example, the square of the number of heads. So capital H gives or is represented by the square of the outcome, that is square of HH is given by 2 to the power 2, which gives 4. Then for the outcome, that is HT, it is then the square of its output or random function is calculated, and its random function's value is calculated as 1 to the power 2, which also gives us 1. So TH is also having the same kind of calculation. TH is represented by 1 to the power 2, and it also gives 1 as the output. And then TT is represented by T to the power 2, and it is represented by 0 to the power 2, which gives 0 as the output. After having gone through these given instances, we can say now what are finite or countably infinite number of values and what are they called. So these are called as discrete random variables. On the other hand, one which takes on non-countably infinite number of values is called a non-discrete random variable. Like the cases which have numbers over the number line that cannot be put over as instances of points alone, and that which cannot be counted very discretely are called as non-discrete random variable. So summarizing, we discussed what is a random variable, how a random variable function or a stochastic function is also elaborated, and along with that we tried to showcase an example over where the output of an experiment is represented in the form of a random variable function with the outputs values given as some result. And then we discussed about discrete random variable and non-discrete random variable or non-countably infinite random variable. So that's it. This will be all in this topic, that is random variables in statistics. So if you like this post and found it informative, then please like it and subscribe the channel for forthcoming topics related to statistics, maths, data science and AI. Hence, thanks again for watching Data Science and AI Quest. Have a great day.